Hello everyone, welcome to Learn Overflow. In this video, we will discuss another LeetCode problem. There is a minimum deletion to make the character frequencies unique. Let's see what this question is. This is a medium level question, and we'll read into the question and understand how we can solve this question particularly. But before doing that, if you haven't subscribed to this channel already, make sure to subscribe to the channel for more such LeetCode videos. So in this question, we see it says a string is called a good if there are no two different characters in S that have the same frequency. Okay, so that means no two defined characters should have the same frequency. That means it should have like equal frequency. It have different, like each character should have different frequencies. Okay, so that's the thing. There are no two different characters in S that have same frequency. Okay. Now, further it says like given a string S and return the minimum number of character you need to delete to make S a good. Okay, so we are given a string S and we need to delete characters from it. Remember, we need to only delete characters from it and to make the string a good string. Okay, so that's the minimum number of characters we need to delete to make this a good string. Further it says the frequency of a character in a string is the number of times it appears in the string. So it explains us further that when we say the frequency, that means the number of times that particular string, like the particular character appears in the string. Okay, like for example, if there is AAB, then that means A is 2, like frequency of A is 2, while the frequency of B is 1. So that's the idea behind this actually. Further, what we see, let's see what are the examples given to us. Examples being AAB, we see like 0 being like AC is already good because the frequency of A is 2 and the frequency of B is 1. So we can consider that this is good. Look further, what else we have? We have like AAA, then BBB, and then CC. Okay. In that case, we can it says like what we can do, we can delete 2b resulting in a good string a b and cc, or another way is to delete 1b and 1c. Okay, so thus it also becomes like, see there each of the characters numbers, like the frequency of each characters are different. So you might think like why we are deleting b in the first case. We could have deleted, like in the first case we could have deleted a also, right? So yes, we could have deleted a also, but it's more like we are just like they are hinting us towards a solution, you can say, by this explanation. Yes, you could have done like something like a and then bbb and then cc, that could have done, but why we went up to the b, we'll understand this further when we try to think of some kind of solutions for us. Okay, so that's the thing we need to do. So yeah, ultimately, like either way, we find that we have to delete two characters out of it. All right. So you may ask like what would happen if we have something like say a and then we have something like b, c, d, and then e. Okay. So if you have something like this, what would happen? So if we have something like this kind of string given to us, such that like only two times a is there and b, c, d, and e all are one time, remember we need to delete elements, like we cannot add any element, right? So what we can do, we need to delete cde, like we need to make 3 deletions so that our our whole string, like all the characters in a string have different frequencies. Okay, so that's the idea we should go ahead with in this kind of question. So also look, when it says the minimum number of characters, more or less you can think we should have a greedy kind of approach. Okay, so what can be our approach in this case? As I said, there's a hint of for us in this explanation. So what can be an approach for us in this case? The approach can be keep a frequencies array. Okay, a frequencies array of like 26 characters in it. 26 characters being like the all the a to z being it. Okay, we need to see one more thing, that is a constraint. to know like whether it's 26 characters needed or more than that. Let's see that once. Yeah. So over here, see the constraint. Constraint says S contains only lowercase English letters, right? S have only lowercase English letters. So if that is so, then we can be sure that there are 26 characters are only there. Okay. Also, it says the length of S is at least one. Like it cannot be null characters being sent as a string to us. Okay, that is not possible. So, and it can be a far bigger element as well. Also, look at example 3.1. Example 3, you will find that the character need not to be in a completely sorted fashion. The character can have like maybe in a like random fashion as well, like C E A. So the in that case, you cannot go ahead and do something like you cannot go ahead and have a sorted character and remove from them easily. So for that thing, for that exact thing, we need this kind of exactly like to have a frequencies array. Okay, in the frequencies array, we can actually go ahead and uh, keep the frequencies in track. Otherwise, over here we cannot actually keep the frequencies in track. Okay, we will end up like well, like we will end up having wrong calculations anyway, because we don't know like how many times when we are at this position, we don't know how many times B is being repeated in the whole string, right? So that's the idea, to have a frequencies array in the first. Now, what else we will go ahead and do is basically we will check that we have this like we what are frequencies that is made out of this. Okay, like we counted the frequency of all the elements and made a frequency array out of this. Now what are the thing we need to do further is like have a like hash set or particularly hash set to have a count that once say like what I was hinting like this example to was saying, say you came across A and A has a frequency of 3. So you add this 3 frequency like integer 3 to our hash set. Okay, so to note that A, like there are some elements like there is an element that has or that is already being 3 in it. Okay, next we come across B and we come look for the frequency of B. So frequency of B, we find that it is also 3. So in that case, what we will do, we will simply remove one element from the B and see if our like particular hash set contains 2 or not. Like our particular hash set has a 2 or not as its value. Okay, like you remember like hash set cannot contain duplicates, so it won't have like multiple 3 in it. So once we have come across 3 before, so it will not have multiples in it. So we can simply go ahead with like a hash set that contains and it will return us the exact value for us. Okay, and then we come across C, and in C we find a length of 2. Remember, like in B we actually removed one element because removing one element made us to believe that there are 3 elements, and then we come across B that we made it to be 2 elements, that is only the like first 2 elements anyway. Next we come across C and we find that the frequency is 2, and we find 2 is already within our hash set. So if we have 2 already in our hash set, then we need to delete one element from this, like a number is already there in hash set, so we need to decrement the number. And then we find that decrement is to 1 makes our hash set like we find that it's not there in our hash set, right? So that's the thing we can do easily, and then we can find a solution to this. Okay, so let's to go ahead and try to write the solution over here, and then let's understand how exactly we went ahead to write the solution. Okay. All right, so here we find that we actually wrote the solution for this, and let's understand what exactly we try to do over here. First thing first is we took a frequencies array. So this frequencies array will have 26 character element. Okay, so that's the length of the frequencies, like all the lower small lowercase English letters we have. And then further, what we did, we took like each of the characters of our string s, and then with the particular character, we added them, like incremented the character count with the frequency count in our frequencies array. So what exactly is this? Like C being the character over here, okay? And then C minus A is actually converting this character to our integer value, right? So C minus A is something we are getting out of, like we are converting it to integer, and then we are incrementing this like the frequency to be like we are incrementing our particular frequency we have over here, right? Next, we took in state like a container state, and then in this, what we do, like we went ahead from 0 till 26, 0 till 26, like all the frequencies we have over here, right? And what you find that if the like the frequency of I is greater than 0, that means that particular character we came across has a frequency in our array. And then we did something interesting. Look here carefully. This is a container dot add frequencies of I. Okay, so containers dot add frequencies of I is actually adds our current frequency to our like this hash set. Okay, but this particular function returns as a boolean value. Just read through his documentation, you will find this container like this hash set dot add function we have. So this returns as a boolean value, and this boolean value is like whether the particular value is being added or not. So if this particular value is added, that means that particular frequency is not there within the hash previously. Okay, so what we did a like, so in that case that will return like our containers dot add return as a true. Okay, and then we did what, we make a not of that particular return type, so that means that becomes a false for us. So if our frequency is previously not there in our like in our container or in the hash set, so that means we don't need to worry about reducing or doing anything with it, right? So that becomes a false for us. Okay, next thing is like whenever we come across like the particular frequency is there within our hash set, then this container like hash set add function return as a false value, return saying that it couldn't add the value, and then you do a not operation of that. So doing that, what happens, once we do a not operation, our particular like the value becomes true because it returns as a false there. Next it becomes true, and it's true and true, then we do what, we decrement our frequency counter. Okay, like we decrement our frequency like the same case we were doing in our example of like we came across to B, and we find that 3 is already like the frequency 3 is already there, so we decrement B to 2 characters. Okay, the next thing is we find that again 2 is not there, so we can go ahead. So the number of times we decrement the character, we count like how many times we decremented. Okay, and like the count of how many times we decremented is the final answer. Okay, the next thing we come across is C. We find that after B being decremented, the 2 it has a value of 2, and this value of 2 is being added to our frequencies array. So now when C comes across in the frequency array, we find that this particular 2 is like we will find the 2 is already there in our container, right? So in that case, what we will do, we will simply reduce that frequency for that particular C, and then increment our like the deletion counter. Okay, so that's all the question is all about. Okay, let's understand what's the complexity and all of this question. So the complexity is more or less like you can say order of n. Why I'm telling is order of n. Look here, n being the length of the string. Okay, like for whole string, remember the string length can go up to 10 to the power 5. So that's a huge number. Let's understand further why I'm saying this. So this can go up to 10 to the 5, and for this you can find like the order of n will be there. Okay, next move ahead. In this particular loop, you may say why this particular loop is not considered. Look here, we have 26 character frequency. Okay, see, our frequency of a particular character is 1000. Okay, a particular character frequency is 1000, and then we come across another character whose frequency is also 1000. So how many times will we go ahead and decrement that? I mean, for this particular loop, for loop, it will go from this I equal to 0 till I equal to 26. Like, anyways, it will end up having 26 values only, and those are constant values. Okay, and then if we come across to, like say all the 26 elements of all the 26 characters are there within our string, and each character have a frequency count of say 1000 each. Okay, then what will happen if each character has a frequency count of 1000 each? Then how many times we actually need to decrement the number? It's more or less like we will go ahead and decrement each of the numbers like 26 into 26 times, right? So it's like each of the number will get decremented, say from one time to 25 times. That's the maximum decrement you will do, because then it will make the whole like the whole string as like a good string, because like no two characters have the same frequency. Okay, so it's like we can understand that the whole task we have over here is like it's a pretty constant loop we have over here. We cannot have a like loop over here that is greater than 26 into 26, right? So that's impossible. So you can say like this is a pretty smaller loop, like 26 into 26, with respect to a loop over here that is that goes up to 10 to the power 5. So you can see which one is more dominating over here. So 26 into 26 is more not that dominating. So we came across that the frequency, like the time complexity, actually order of n being the n being the length of the string. Okay. If you look at the memory complexity is more like you see like there are frequencies array over here. So it's like only 26 characters what we needed over here. Okay, nothing more than that. So I hope I can make you understand how this particular question works and how you can actually solve this question over here. So thank you all for watching this video. Make sure to subscribe the channel if you haven't already. Also, comment down your thoughts if you have any doubts related to that, or if you couldn't understand anything, or if you have if you want to have discuss any other approaches to this particular question. So make sure you just comment down on that. I will be happy to help you out in the comments as well. So thank you all for watching this video. Hope to see you soon in my next video as well.